In triangle ABC, if angle A is 70 degrees, angle C is 30 degrees, and side B is 8, find A and C. So let's draw a diagram to take a look at what we're dealing with here. So if we draw our triangle like so and label it ABC, we're told that A is 70 degrees, and we're told that C is 30 degrees. Well, immediately, in any situation where you're given two angles, we know that the third angle in the triangle has to add up to 180 with the other two. So immediately we can see that angle B is 180 degrees minus 70 degrees minus 30 degrees, and that's just 80 degrees. So immediately we have our third angle, and we're told that side B is length 8. So let's label that as well. So again, we just found that angle B is 80 degrees, and we're asked to find the other two lengths, the other side lengths. And this is where the law of sines is useful. This is a ASA case, and so using the law of sines, we can see that, well, side A is over here, and side C over here are related by the law of sines. So A over sine A is equal to B over sine B is equal to C over sine C. And because we know both B, the angle, and B, the side, we can use that to find A and C. So if we solve this, so we find that A is equal to B sine of A over sine of B. And again, we know all of these now. We know that B is 8. Sine of A, that's sine of 70. And divided by the sine of B, which is 80 degrees. And when we compute that, we get about 7.6. And then similarly for C, C is going to be B. If we solve for C over here, we're going to get B sine of C over sine of B. So B sine of C over sine of B. And when we plug in, well, B is 8 and C is 30 degrees and B is still 80 degrees. And when we compute that with a calculator, we get approximately 4.1. So that's how we can solve for the other two sides in an ASA case using the law of sines. As another example, in a triangle ABC, if we're told that angle A is 110 degrees, angle B is 45 degrees, and side A is 12, we're again asked to find the other two sides of the triangle. So let's again draw a figure to see what this looks like. So now A is an obtuse angle, so I'll draw that a little bigger. So here's A, B, and C. So here's A, as we're told, is 110 degrees, and B is 45 degrees. Well, and again, if you're told two angles, you can find the third. So let's immediately figure out what C is. We might as well. That's a good fact to have. So C will be 180 degrees minus the sum of the other two angles. So minus 110 minus 45. And so that comes out to be we're subtracting 155, and so we get 25 degrees. So C is 25 degrees. We can fill that in. And again, now that we have all the angles and we also have the side, A is 12, so 12 is over here. And now we're perfectly ready to use the law of sines. Once you have an angle and its opposite side and other angle information, then law of sines is great. So again, let's quickly set this up. We have side B over here and side C over here. So we're going to have A over sine A equals B over sine B equals C over sine C. And we'll, again, to find B now, we're given A and its opposite angle. So to find B, we'll cross multiply. We get A sine of B over sine of A. So that's A sine of B over sine of A. We're told that A is 110 degrees, and the side length A is 12. So 12 sine of B, which is 45 degrees, over sine of A, which is 110 degrees. And when we compute that, we get it's about 9.0. And then similarly for C, if we solve for C, we're going to get that C is A sine of C over sine of A. So A sine of C over sine of A. Again, A is 12. C we found was 25 degrees. And again, we divide by 110 degrees. And when you compute that on a calculator, you're going to get that that's 5.4. So that's how we find B and C. So again, the ASA and the AAS cases for solving a triangle are really the same, because knowing two angles, you can immediately find the third angle, and then you have one side given to you, and everything else follows from the law of sines. Let's look at another case that's solved using the law of sines. In this case, we're given an angle and two sides. So let's draw a picture to see what we're dealing with here. So we have angle A is 40 degrees, and we'll put C up here. And then B, this is where we have what's called the ambiguous case, where B might be here, it might be here. I haven't drawn this very well. Let me redraw that a little bit better. So something more like there. These are the possible values of B. So there's our 40-degree angle for A. And we're told that side A is 4. So 4 can be over here or over here. It might swing one way or the other. And side B is fixed at 7. That's over here. And then, but again, angle B might be one of two values. And before we can figure out which case we're in, we need to just try and solve for B. We just try and use the law of sines and see what we get. So remember how the law of sines work. We're going to use the fact that sine of B over B is equal to sine of A over A. You may see this either this way or with the reciprocals. You may see B over sine B and A over sine A. You can use it either way. I'm just writing it this way because I know I want to solve for sine of B, and so this way will be a little easier. I'll find that sine of B is just equal to B sine of A over A. And this is all information I'm given. I've been given B, I've been given A, and I've been given angle A. So if I write this out, well, B is 7, and A is 40 degrees, all over side A, which is 4. And when I compute that, what I get is that this is approximately 1.12. And now when you see that sine of B is equal to a value bigger than 1, that immediately says to you that there's no solution. There's no way that sine of B can be 1.12, so this has no solution. And pictorially, what that really meant is that this edge over here, this side of the triangle over here, was too short. There was no way for it to reach down to the other side of the triangle, and so there was no way that we could complete this triangle. It was inconsistent. So that's what happens when there's no solution. Now, in contrast, let's look at an example where it's very similar, where A is told to us to be now 20 degrees, and then side A is 4 and side B is 7. So similar picture, but now we have an even narrower angle. I'll draw it similarly though, so something like this. So here's our A, and again we don't know whether B goes like this or like this. So here's 20 degrees, and we have 7 over here, and here's C and B, and maybe B over there as well. We're not sure yet. Okay, well, let's set it up like we did before. We found that sine of B before was equal to B sine of A over A. So let's try that. Sine of B is B sine of A over little a. B in this case was 7. A now is 20 degrees. And again, little a is 4. All right, now if we compute this, what we get is that this is approximately 0.598. And that is a perfectly valid value for sine of B. And so what we can find is, well, we can take the inverse sine. So B will be the arc sine, another word for the inverse sine, of 0.598. And that comes out to be about 37 degrees. So that's one value of B. That's the value of B over here, where B is acute. But remember, there's another option over here. There might be another option over here where B is obtuse. Again, we know that there are two angles that have a sine of 0.598. One is in the first quadrant, one's in the second quadrant, and we find that other one, or we find the other value of B by taking the supplement 180 degrees minus 37 degrees, and that comes out to be 143 degrees. So we have two possibilities for B. We still need to check to make sure that this is an option, and the way we check that is by taking the 143 degrees and adding it to 20 degrees. We get 163 degrees, and that leaves an angle left over for C, and so this will be consistent. We'll be all right. Anyway, let's work those out in a little bit more detail. So let's see. First, so we're going to have two cases. This is one of the cases where we have two options. So label this 1 and 2. So in case 1, when B is 37 degrees, well, if B is 37 degrees, then our triangle looks something like this. 20 degrees, 37 degrees, and then up here, C will be 180 minus those two. So C will be 180 minus 20 minus 37. So we're subtracting 57, and that leaves us with 123. Okay. And again, we also know some side lengths still. We know that side B over here is 7, and side A over here is 4. So this doesn't look perfectly to scale, but that's okay. And now we know angle C, and so this is just like our ASA case where we have two angles, we have sides, we can figure out the third angle and then the third side. So in this case, we'll figure out that C over sine C is equal to A over sine A, and cross multiplying and everything, we'll find that C is equal to A sine of C over sine of A. Oops. And again, we figured out what C was. It was 123 degrees, and side A is 4, so 4 sine of 123 over sine of A, which was 20 degrees. And when we work that out, we get 9.8. All right, and then we still have that other case. So the other case was when B was equal to 143 degrees. And so that looks something like this, where so here's B is 143, A was 20, and again we can figure out C just by taking 180 minus these two angles. So C will be 180 minus 20, which is 160, minus 143, which is 17. So C will be 17 degrees in this case. And again, we still have the other side lengths. We have that side B is 7 and side A is 4. And again, we just have that one last side defined. And like before, it'll just be C is A sine of C over sine of A. Again, A was 4. And now C is 17 degrees. And again, A is still 20 degrees, sine of 20 degrees. And when we compute that, we get C is equal to 3.4, roughly. So 3.4 in this case, and in the earlier case, C was 9.8, so we can label those. So there's two possible triangles where A is 20 degrees, side B is 7, and side A is 4. And we found them by using the law of sines. Now, we have another situation where we're told that angle A is 40 degrees, side A is 7, and side B is 5. So similar, but a little bit different than what we saw before. And so a picture in this case is similar to what we saw before. We're going to have something like so here's our angle A is 40 degrees. Our side A now is long, it's 7. And side B is just 5. And one thing to think about, just pictorially, if you think about what this means, because 7 is longer than 5, we can't have that case where the other arm was swinging and could possibly meet in two places. Because side A is longer than side B, there's only one way that the side of the triangle can meet, and it has to meet over here. So pictorially, we can sort of sense that there's only going to be one solution in this case, and that will be matched when we try and use the law of sines. So let's use the law of sines to see what happens here. So as usual, we're going to be trying to find that angle B because we have the side opposite angle B. So we have that A over sine A equals B over sine B, and we won't worry about C for now. And what happens? Well, when we cross multiply as usual, we're going to get that B. Well, again, we're trying to find angle B, so if we solve for sine B, we get that sine B is B sine A over A. And when we compute that with what we know, we find that this is about, well, it's 5 sine of 40 degrees over 7, and that comes out to be about 0.46. So we find that B will be the inverse sine of 0.46, and that comes out to be 27 degrees approximately. So we have 27 degrees there. And again, there might be another option, right? We also have to check the supplement of B. So the supplement 180 degrees minus 27 degrees. That comes out to be 153 degrees. And this time, this case, this does not work. So this is we reject this possibility. And the reason why is that 153 plus 40 degrees is already 193 degrees. That's too big, right? The sum of the angles has to be 180. So we reject because 153 degrees plus 40 degrees is already bigger than 180 degrees. And so because of that, this case is out. And so we just have that B has to be 27 degrees. And again, that matches our geometric intuition that there really was only going to be one way that this side of the triangle could meet over here. So B has to be 27 degrees. And that tells us what C is. So C is going to be 180 minus 40 minus 27. So that's 180 minus 67. That comes out to be 113 degrees. And so if C is 113 degrees, we can again use our law of sines, and we're going to use that C over sine C is equal to A over sine A. And we solve that for C. We get C is A sine of C over sine of A. And plugging in what we know, we have that side A was 7. We found that angle C was about 113 degrees.